All right, howdy folks, and welcome to Alwa's NES Awakening. My name is Paul. I go by InfiniteNesLives. We are porting Alwa's Awakening to the NES. This is stream number 15. If you're watching on YouTube after the fact, there's links in the description to the end where I go over the recap and any other interesting moments. So we are working on scrolling into rooms. We didn't actually execute any of our new code last time. We're already able to scroll into our room left and right. But now we're working on, we're starting with scrolling down, just because that should be a little bit easier. I'll get this guy over here. Whoops. Yeah, that's what we need. We wrote a bunch of our code, but we hadn't got to execute it yet. So I think the first thing I might actually do is just get the code working to scroll at the speed that we want. That's like the easiest thing to do. 4 pixels a frame. We get to the end of frame, stop. So once we have that going, then we can start doing the tiles. And if we get that working, then we'll do the attribute tables. But I don't think we're going to get that far this evening. We'll just see how things go here. So now when we push down, we set the scroll trigger to scroll down and similarly for scroll push up. So scroll dir gets set. And so we have a horizontal mask somewhere. I thought, yeah, horizontal bit is bit 2. So here's where we check that. If phone's gonna be on silent, I'm just gonna so branch to vertical code. Let's look and see how I did this with the horizontal. So this is what I did for the horizontal camera move. We set the camera bit to designate that scrolling is occurring. The camera's moving. Yeah, some of this similar code will probably work fairly well. The horizontal is a little different because we have 2 name tables to work with, so we update the name table off screen and then scroll into it. Vertical, we don't have that luxury. We only have what would have been the 4 rows of tiles. So we have to update at the same time. Let's copy this stuff down for now. So this is the end of the horizontal, and here's the vertical. I'm just going to put it up here for now. Let's comment out all this other code, because it's all untested. Let's make a bunch of notes of what I think I wanted to do. So I don't think we really need this camera bit. Okay, so here I was checking if left, the up left bit, but we can use it for the up. So this one is up, and this should change to down scroll. So the down is here. Let's make sure I get my I know the D-pad changes, but does the scrolling change in the same methodology, or my math going to be all wrong? So scroll of 0 is this top left corner. So as we scroll down, we're going to increment. Yeah, add 4. So that's right. And up scroll is subtracting. Okay, so everywhere I scroll here, although all of my, oh, it should be okay. Okay. I might have 2 check exits though. All right, let's check this here. So I still don't think I'm I'm not setting the scroll. We have to have some sort of soldering iron shutting off. Anyway, let's see. So load scroll dir. If up. But really it's if down, because we and with the up bit, and if it's clear. If down, jump to down scroll. Up scroll, subtract 4, so load Y. Oh, we don't have to increment scroll name table though for vertical scrolling, so we don't have 9-bit math to worry about. We're just gonna wrap around. So subtract 4, and then we just jump. Down scroll, load scroll Y. Load store. So I'm checking vertical exit now. This check's not going to be as easy as horizontal. So how will we know? And really we'll know it'll be different for up and down. So our scroll position in the Y, it starts at 32 because we start displaying right. I'll go look at our, yeah, it should be 32. I'll go look at the code to verify. But we're having our sprite 0 hit and we're resetting scroll on line 31, and so the next scan line should be 32, which is here. Yep. 31. Oh, I guess it's gonna get incremented 32. 31 is the last scan line of the heads-up display. Let's there no, that's not what I want. So let's run frame, scroll left, run frame. Our name tables are probably getting updated right now. There we go. Now this, I have it different for X and Y. I'm not going to see all the math here anyway. Boom. I disabled all of my up and down scrolling code right now. Anyway, I'm going to assume that's right. That's what it's got to be writing anyway. So so scroll is 31. If that's correct, we're going to scroll. There's how many pixels in the playfield? We got, so it's, the screen is 30 tiles tall minus 4, so it's 26. 26 tiles times 8 pixels, so it's 208 pixels in the playfield. start at 31. Well, I think so. I know that I just got to keep aware of this. I know that for the X scroll, we're doing it before V blank, so the Y gets incremented just after we write to it. I'm just not sure for the Y scroll if that's true. Maybe I have an old ROM we can load up. I should always save old ROMs. I'm not very good at that. So these don't actually scroll. This is an older one. Or too recent of one. This one I don't think is actually. And this one is. Oh, I think I scroll like this. Yeah. I don't know if I'm always writing though. Nope. So, yeah, I'm getting the writes done way before. So when the value I write is, hey Ben Shaku, how are we doing? The value that I write to the scroll of Y is 31 because that's the current scan line that I'm on, and then the PPU will automatically increment it. Yeah. Yeah, so it gets incremented 32, and then it starts displaying on 32. All right. Oh, we're having problems. Well, let me know if anything else comes up. Maybe it's just... I was thinking about different streaming bit rates. It's annoying that you can't stream at one bit rate and record at another, but I guess that makes sense. I don't know. For recordings, it's nice to have 1080p, but anyway, if you're having problems over there, let me know. It might be best for me to switch to lower resolution for streaming and just deal with it. Hey, Bridgewater. Good evening. All right, so we're working on, right now I just want to have, I better load up the right ROM here. Trying to get our, yeah, but if it's just a problem on the Japanese side, then probably would help for me to change my bit rate, my resolution, and just stream less data, make it so people can see it. So keep me updated if you're still having problems. I could start and stop the stream, but anyway, you're a good test for, I mean, depends upon your internet connection too, but I want people to be able to see stuff or watch it, then have a higher resolution. Okay, so we're just working on our vertical scrolls right now. Then we'll do tile updates. Then we'll do attribute tile updates. So we're checking if we're pushing up or down on the Dpad, and updating our scroll value. So the value that I write is 31 because when the write happens, it's the last scan line of the HUD, and then the PPU automatically increments it. So we're gonna go, there's 208 pixels per frame. So, okay, so here's the situation. We have, so this is for up. Let's think about the down right now because that's easier. Well, they both wrap around. Okay. Spell, Paul. Scroll. Y. Written. Last. Okay, so we start 31. We're incrementing. Okay. We're incrementing as we scroll down. So 31 plus 208 equals what? 239, which is too much because it's only 230, right? Yep. I'm gonna second guess myself. No. Yeah, 240 scan lines. So 239 is, oh, that makes sense, but, oh, you can't see anything? That is weird. Oh, when I go there, oh, that's because I have, there we go. Sorry, I had that on the wrong screen. Yeah, got it fixed. Thanks. Yeah, I had my browser on my side screen, not my main one, and so I could see it, but you guys couldn't. Okay, so here's the situation. This makes sense now. So we're scrolling down. The very first... All right, better look at it this way. So when we scroll down, our play field is from here to here in default. And then the first pixel of the next play field is this one right here. Now that, so the last one, it'll be 239. PP will increment it to be 240, but 240 is not a valid scan line because it's 0 to 239. So we have to, the very final one will happen when it's 239, but we need to set that to 250. Oh shoot, how's that gonna work? Well, the PPU should actually update it. Won't the PPU increment it from 239 to 240, which will be 0? I think it will. Or won't it? Yeah, I think it automatically... It should. Well, I'd like it to, and I think it does. Trying to remember where that talked about that. Yeah. You have to use a high starting scroll position to end up in the attribute table, don't you? Yeah, I'm not 100% sure. I think it... Anyway, maybe we'll just go with it and see. If it breaks, then we can... we'll assume we're right until proven wrong. So... because the PPU will actually get to do that increment for us. Maybe if we set the scroll to like 245 or something like that, then it would be broken. And I think that's what you're saying, Bridgewater, too. So if we have it 239 at the end, and then once it reaches the end of the scan line, it'll automatically increment it for us. The only thing is our scroll variable won't really be right anymore. It'll... Anyway, think about that, not forget that, I guess. Because it increments scroll in the PPU, but not for us in our variable. So then PPU auto inc to 0. We still need to update. Okay. So down scrolling will be done when scroll Y equals 239. Well, that'll be the last one. And then what was I doing? I was clearing the camera bit. So in the horizontal option, I was checking afterwards, but here I can, the check is different for horizontal and vertical. So I'll just have this be what to do when we exit. So I store it, then compare 239. And if it's not equal, I'm going to branch to horizontal, or this should be vert. That's not what I want to do. Okay, so compare 239. Okay, so that let's do the same thing for PP for oh, okay. So here the code is gonna, if it's not equal, it's just gonna roll through to vertical exit, which is fine. We haven't fixed that code yet though. Okay, so now Well, part of me just wants to come back to the scroll up because that one's going to be even more messy. Let's make sure we can do down first, because scrolling up, we're going to have to skip over the name table. So at first we have to check if we're skipping on the name table, and then we do anyway. So let's make sure we can do down first before we go try to write a bunch of code that's probably going to be buggy anyway. Okay. So when we exit, I think it's actually already in there regardless, but anyway, because we're not doing the name table increment. So load scroll Y. Oh, here I'm checking if we're done. I'm only coming here if we're done. So the load scroll dir, and we're going to clear the camera mask just like we did last time, and then this default bit. That part wasn't implemented, but so now and this goes back to I use the scroll dir. I use the scroll bit to check if we're scrolling. But that scrolling isn't really scrolling, it's updating. In the camera move. I want to change that variable because it's confusing. Let's see. So we have this go to default, but go to default's going to need to know the directions and all that stuff too. Horizontal has 2 steps: scroll, which is update, and camera, which is move the camera. Because horizontal camera move, I'm checking if the camera bit's clear. And with the horizontal, I'm checking the scroll bit. If the scroll bit's set, then I update. If I'm done with that, then I clear the scroll bit and I set the camera bit. Vertical. Oh, here, see, I got rid of the camera bit because we don't need it. So let's just clear the scroll bit instead of the camera bit. So our updates are done and the scrolling. Done, updates, scroll. So the direction will still be there. I'll come here again because I'm only checking the direction to come here again. I'm not checking the scroll. So maybe I should be checking for the scroll here. And then later we'll have to add a check for the update or go to default. Whoops. So when we're scrolling vertically, that's all we know is the vertical bit set, or the horizontal is clear. So I load the scroller, I end the scroll bit. If it's clear, I go to horizontal camera done, which skips me down here. Oh, Bert. Which does nothing, so it should stop. Okay. It might work. Oh, we have to trigger it to start though. So we push down, we set scroll down, or set scroll there. Maybe that should be enough to trigger it, because scroll down is set, scroll is set. It's not scroll none. It's something, and the horizontal bit is clear, so it'll jump to scroll vert. Which will start our code, so I think it'll work. Got a range error, line 68. That's an NMI. Not exactly sure how That change caused that. I'm leery of that. Hey, it looks like it worked. I'm not sure that scroll position is right. We have. Is that final scroll right? No, that's not what I want. So tell me what the active scroll is. Limited NES lives don't matter. I guess. I'm infinite NES lives. Snake Grunger. How we doing? Trying to see how I can tell if it's. Well, I think it's right because it's. And I guess we should have 2 extra because there's a black pixel here. I'm just trying to figure out. I think it's good. What's the these little tiles, they've got a little stripe of white, which looks like we're off by 1. Yeah, I think we got too many pixels there. That makes me think that the PPU isn't incrementing it to 0. I'm not certain. How can I be certain? Let's make this, whoops, not that big. Yeah, so I can see all pixels here. And the last line should be gray. And it's not. And the last of these oops, spikies we should be able to see the bottom spikes of like this guy. So we need to move up 1 more. And oh, you know what? I'm just taking stabs in the dark here, but no, I'm not going to say that. So let's look at this. Instead of just guessing, I want to have some informed information here. When the rendering is enabled, PPU increments the vertical position. The effective Y scroll is incremented, which is a complex operation that will correctly skip attribute tables. This is at .256. Correctly skip the attribute table memory regions and wrap to the next named table appropriately. See wrapping below. Wrapping. Following pseudocode explains how the wrapping is performed. Y increment. So if rendering is enabled, .256, and maybe, oh, we might not be doing it early enough at all times, especially if the screen is paused. Because when we're stationary, and I might be able to, let's do this. See if maybe it's right, and then it jumps back as soon as we're done scrolling. So let's pause here. Hit down. Well, we got to reset actually. Because, all right. Hit down. Render a frame. Turn this off. Okay. So here we start scrolling. Our writes are happening all the way back here, so it should be incrementing properly. That looks pretty good. Or we might still have an extra pixel there. Yeah. We're actually off. It looks like we're off by like 2 pixels. Yeah, we're off the whole time. Because that blank line. What you're doing now, is it learning to code the NES PPU or making new engine for a game? Kind of both at the same time. I'm making a new engine for a game, and I am learning to code the I mean, I have basic understanding of the PPU before this, but you never stop learning. So this is the first time I've written an engine for the PPU, and so I'm learning at the same time. I think it needs to be. I guess I'm not getting the increment. Because see, this little gray line should not be here. If we're doing it on, oh, it doesn't like that. Resizing while I'm. You can see it here. Yeah, it really hates it. Well, I mean, yeah, it's basic, but it gives you a lot of raw access. So, all you have is raw access. So, the fun thing about that is if you know how it ticks, then you can do a lot of fancy things. It's just it's tricky in a lot of its timing but anyway, see, this should not be there. So we must have been wrong. Because we're not actually... Wait, what scan line is happening? 31. 2000. So these are happening. Oh. These are happening. This is finishing after 256. Yep. So the first time, I guess, we actually want to increment Y scroll by 1. Because the auto increment happens at 256. Okay, that's why. Now, it works with 31 when it's 31 when we're when we're not scrolling, because the writes are happening beforehand. But that's not the case while we're actively scrolling in the Y. So that makes sense now. Okay. Good. So we gotta detect that somehow the first time. So if the first time Y scroll is always going to be 31, so I guess we could just do that. The PPU scroll writes happen after .256 while we're actively scrolling. So PPU auto Y inc doesn't happen. So let's see. LDA scroll Y branch not equal, or we gotta compare to 31. Yeah, the NSPP is quirky. It's a far shot. Yeah, from this 2600, you're basically drawing the bitmap of the pixel field every frame, I think. Yeah, and TMSS 2988. Yeah, I think the master system. I haven't looked into it heavily, but there's some things there that I think they got better color choices and not as much attribute problems. It's probably the most equivalent, and there may be benefits and drawbacks. I don't know if one's clearly a winner or not. Plus, there's a whole other system around it. So let's see. Compare 31. Branch not equal. We're just going to skip. Inc scroll Y. Okay. Yeah, California Games is better than the NES. Yeah, I've heard comments about the SMS PPU. Oh, gotta spell scroll Y correctly. Scroll. That's not how you spell it. I've heard NES developers, Brad Smith specifically, Lizard creator, wishing he had some PPU features of the SMS. Background tile priority instead of sprite priority and such. Yeah, I'm not too educated on the SMS. Oh, that's not good. Oh, right, because our check is wrong. We did 239. It'll be 240 now. And let's change these 31s. And these 239s, 240. There's preferences in here. Options. Break options. Break on. I don't want to break on power reset. Oh, it's not. Maybe I just had it paused. Okay. Yeah, NES PPU. Pain and pleasure. Indivisible. What's the SN 76498 in? Is it in SMS? No. Hellraiser. Oh. So it it looks like we're not. Oh. Okay. So we were talking about at the end, if we get our auto increment, well, it will auto increment past the attribute tables, but we're doing the right after the auto inc is done, so we don't get that luxury anymore. And so now what we're seeing is attribute tables rendered as tiles. All right. So we should have expected that. Okay, so, and really, so here, compared to 240, we branched not equal vertical cameras done, but we lost luxury of PPU auto inc since after dot 256. So we want to okay. I think it's working. Because we start here. Boom. Now every time after hit down, it actually scrolls 256 dots because we didn't reset it to 31, but it's behaving the same way we would expect. And look, we're all aligned. Okay, sweet. So let's do the up. Now. So we gotta, when we get to 0, we're gonna display that 0. But then the next one, if we enter and it's 0, we have to jump past. Okay, so we're going to subtract 4. Well, and what we can do is if we just subtracted 4 and now it's negative because we borrowed. If negative, now I wasn't making sure that the carry was set because I didn't care before. The gap thing where the status bar sits is supposed to be visible. Well, yes. We haven't loaded the tiles into there yet. Because, so think about it this way. When we're doing our vertical scrolls, we are working within this is the same name table. We have vertical mirroring, so we have the luxury of the other name table for horizontal scrolls, but for vertical scrolls, we're doing it all within that same exact name table. So we're going to start updating our tiles here, and we just haven't done that yet, but we're scrolling straight into it. And so that's basically our buffer. What that heads up display for tile rows it becomes our buffer to where we have to make our updates. And there'll be the trailing section will be off screen, but yes, it's visible now and it'll look proper when we're doing the updates. When we update the tiles. Okay. So, oh wait, I have subtract instead of subtract with carry, and subtract sets the carry. So really I want to branch, so if carry is so we want a branch of carry set because that means there wasn't a result. What about negative? What is there a I think negative's the same thing, but there's overflow. Anyway, I'm going to stick with what I know. Branch of carry set. No attribute table skip. So when we jump into the attribute tables, we want to set the scroll to what, 230 minus 4? Or no. 240. Yeah. So 236. Whoops. Okay, so set to 236 if we jump into the name table, or into the attribute table to correct that jump. And then it should still work from there. Now, we know we're done if we're 16 tiles from here. So 30, if it's 64. So if we're 64, we're done. And if we're done, we're going to jump to vertical exit. If we're not done, we're going to jump to vertical camera done. So A equals scroll Y. Compare to 64. Branch equal vert scroll done. Otherwise, we're going to jump to vertical exit. No, branch not equal. Comparing to 64, if it's not equal to 64, then we're just done scrolling. Okay. Let's see if we vert scroll done. What did I call it? Oh, vert cam done. I don't think I want to name it that. Yeah, that's exactly what I wanted. Because I'm not even using the camera bit. Wait, why is it not? Oh, there it goes. I think that's right. Yeah. Because when we're scrolling up, the bottom of the next screen is gonna be this last row. So we should have 4 rows of tiles when we scroll up. Boom. Okay. Good. Yeah, basically that this heads up display, or what would be the heads up display, whenever we scroll up or down, that becomes the top or the bottom. It's our first portion of the buffer. So we're scrolling up and down. That's what triggers my stop when that hits the top or the bottom. And that's all it really cares about. Cool. That wasn't too bad. All right. So now we just need to do things. And this is a better way for me to write the code. The way I was doing it before was tricky. Now I know this code, I can just call. I've been wanting to put things in subroutines. And now we can do it as we write the code. I think I kind of went about it backwards before, but, well, not necessarily. Here, everything's happening at the same time. Updates and scrolling. So it makes a lot more sense how to structure the code now. Have an additional buffer height for the subsequent scrolls in the same direction though. I think this will answer your question. So right now, say I scrolled into this position. Let's just reset it just because. Okay, so we're in this room, and we'll do a down scroll. Okay, boom. Now, here's the issue. If we try to do a left scroll, it's not going to work. I think if I do left scroll, we're going to see another display of the heads up display here. We're basically out of what I'm calling the default position. So every time we scroll out of the default position, but to do a subsequent room move, we have to get back to the default. Hopefully it's not my thing calling you latency issues here. And it might just took me 50 seconds to see your question, or I guess it's before you can tell because it pops up on the actual screen. Yeah, it completely broke things because I was updating. It didn't even work. It just basically crashed. Anyway, so we haven't actually finished the final step because we start in the default position. Anytime we scroll, we end up out of the default playfield position. So the goal is we're going to have to do some jumping around, updates of other tables, jump around, and get back. So that's a whole nother task to be able to handle a subsequent room move. And it's possible that some of this latency from the text is just because, maybe Twitch. I don't have any bots set up or anything like that, but anyway. So let's see if we can call. We're going to do down first. Here's the other thing. This is kind of nice. If it's 31, we can use this as an init section. Let's change this label. This is vert. So duplicate the room into another name table, then flip over so that you're at least ready for horizontal shift, and it'll be ready for vertical if we do it right. Yeah, so here's how the skip's going to work. The horizontal is pretty easy. So when we scroll horizontally, yeah, so horizontal is easy, right? We'll scroll into the left. Oops. We broke the left. Was I reset? Yeah, we did. And the right. Well, maybe we should fix that before we go any further. I think I might have known what I'd done. Anyway, scrolling left is pretty, and right is pretty easy to create in here. We just have to update that other name table, and then we can just name table, flip the name table bit, and jump back in there. When we're scrolling up and down, because we're still displaying part of our name field, we have to go fill name table 0 with the proper data, jump into there, and then update name table 1 and jump back into there. So it's going to be like a double jump for vertical. But yeah, it's going to take some work. All right, so we broke our left code, which it sounds like we're executing vertical code when we don't want to be. Let's just oh, wait, no. Let's just comment this code out. Yeah. Yeah, horizontal is pretty easy though because we don't have to do a double jump. We scrolled from 1 to 0, and then we just have to go back and update name table 1, and then we can jump right back. We don't have to actually scroll into it. We can just, you know, set the name table bit properly. Oh, that didn't actually break it. It's something else apparently broke it. Maybe there's something up above. I don't know if I actually committed. Yeah, I forgot to commit last time. Damn. All right, let's see here. So damn. I know what I can do. Dropbox to the rescue. I gotta turn my Dropbox back on though. Anyway, commit your files, kids. Each stream. Got coffee still. Where'd it go? Yeah, it was because I didn't want to show you guys Dropbox. Never know what you find. All right. Oops, probably doesn't like the fact that I'm... Timestamp 10:36. Did I accidentally just write it? Or am I just because I copied it? Okay. What? That looks like... Oh. I don't think I actually want to execute any of this code. Well, and you know what? I don't know if I ever test my code at the end of the last stream. And so, because I didn't have anything working, I might have actually... Oh, and I had that... Yep, I knew to be suspicious of that. I had that range error in NMI. And I was like, well, I didn't change any of that code. Well, I didn't compile that code ever. So I think it's actually in my NMI where it's broken. Okay. So, well, glad we didn't waste time debugging the wrong routine. So, well, we changed. Gotta think back to what we did before. See if we can just cut out that part. And if that fixes it, but I think it's in all this switching statement I have. Because, so we do the fast horizontal and last. And that's all we really should be doing. So, name table. So we really want to be running this automatic auto name table update. Oh, right here. This looks like a problem. I don't jump over my attribute table row read function. I just need to jump to scroll, I think. It's not a subroutine, Paul. There we go. That was it. I think. Let's so I saw that code commented out, but let's make sure that all right. Those work. Bring this code back in. And I think I might go ahead and commit at this point. Sweet. Okay, so now we can test that theory. What happens when we scroll left? I think we're going to see the heads-up display twice. Nope. Oh, well, yeah. Anyway, scroll Y was never reset. But when we're actively scrolling, yeah, that's why. When we're, whoops, let me do that. When we're actively scrolling, I assume that Y scroll is 31. And so it's good then, but then it goes back to whatever the scroll is currently set to. And we've got it set to, 240 or whatever. Okay. I said I was going to commit. So let's do it. Let's remove this guy. Just real quick, like. Guess I changed some on my make file. That's a bunch of build code. Do I really want to be? Let's no. This is source folder. Okay. Let's make sure it's all code that looks. So we're working horizontal scrolls with updates and camera move. Vert scroll up and down works. No tile or Azure table updates. Still not handling going back to default playfield. All right. Now, we're going to do scroll down first because that's easier. This is our initialization right here. First time we come through, this is where we end up because scroll is 31. So I have some to-dos and stuff down here, but I had a scroll counter. I did all this code and I didn't even want to use it. I had a counter. I do need to know. Okay, so just reiterate here how we're gonna get this done. So scroll up 4 pixels per frame, which we're doing already, which is 2 frames per row of tiles, which is a nibble row of an attribute table. Attribute tables. We only want to update 2 tile rows worth, or instead of 4. So we have to write a nibble worth to keep the buffer from being visible on screen, hidden behind the heads-up display, basically. So we have 4 frames per 2 rows of tiles. So I'm calling this a sequence of updates. First one, we write a row of 32 bytes. Second one, we write the second row of 32 bytes. Then we read an attribute table row, which is 8 bytes. And in the reading routine, we can instruct it to do masking for us. We OR in the new data, and then we write it. So we need a pointer to we need 2 pointers. We already have a pointer to the name table data, but we actually need a pointer to the attribute table data because each sequence of 4 frames, we are writing to both the tile and the attribute table data. Now, with uncompressed data, we can always find, well, the math isn't going to be easy because it's 128 tiles per, per 8 bytes of attribute, I think. Yeah, so let's just get a new pointer. So I called this nat pointer, but it should have been nmt. Well, sometimes it points to attribute tables. So here's my set nat pointer. And I was doing that. It's kind of hacky right now because it just goes by the Dpad direction. I need to actually have some lookup tables. But for now, it just does which room we're going into based on the Dpad. We'll stick with that, but I need to have it set the attribute table pointer too. Okay, so and it's setting, what's it doing? So input is scroll direction, current room. I don't know if that's true for current room, but so I update the NAT pointer and the PPU address on init. Oh. Why do I do that? I don't. Oh, because I'm. Oh. I don't know if I like this. So for vertical, or sorry, horizontal, we always increment by 56, so I subtract it by 56 so that it can be always incremented by 56. I'm not going to do that for vertical though. Anyway. Maybe I do like it, but I don't think I do. Okay, so scroll up. Because I kind of wrote this when I was naive and thinking vertical is going to be similar to horizontal. So I set the room pointer. And then I subtract this. But I don't want that. I'm also... oh, that's two different things. PPU address on it. Well, probably want that PPU address because when we set, we know what that's going to be based on our direction. For horizontal, deck pointer for okay. So I think this initial address is oh. Well, for down it's correct, but for up we're going to start at the bottom and work our way up. So this is my up code. We're not going to work on up yet. Down. So the initial starting address should be right. So let's pattern tables, PPU data. Could just add 88, but at some point we're going to be compressing these, and I might want attribute tables somewhere else. I don't know. I haven't decided any of that, so. We'll just have them defined after each other, and then we can use those labels if we want. Oh, okay. So down. We set it to the beginning. The way to kind of get rid of this problem is increment the pointer after we're done, not before. But then I think my flag checking or something was simpler. I don't know. And then this is just attribute table pointer, starting address. I think we're gonna, well, no, it should be okay. All right. So check down now sets the room pointer properly, and the PPU address is in name table update in the beginning part of the buffer. So this is just set. So the all right. We do need to know which portion of the segment we're in to know if we need to do a tile update or if we need to do an attribute table read or write. So we need some sort of variable for that. Now we can just use scroll count. Scroll count's supposed to be 0. To determine which type of update. Name table, attribute table, read, write. Assuming we clear it, let's just do it. Oops. All right. So first thing, we need to determine which type of this scroll code should be all the same. I don't know if there's much benefit in embedding this update code inside there. I guess it depends upon if the update code depends upon which direction we're scrolling. We should be able to make it so that it doesn't. If the pointer is set properly to the top of the bottom, we could, inside the code, change, increment or decrement the pointer, update the pointers inside. Let's try to go with that route. So, which segment frame are we in? Now we need to increment the scroll count every time. So where should we do that? Maybe when we're done with this portion, because vertical scroll, yeah. Update done, or buffer updates, I guess. Jesus. Ink scroll count. I think that actually wants this. Okay, so so we have 0, 0. This is binary, the last two bits, 0, 1. So this is name table row 1, row 2, read, write. So if bit 1 is clear, we're in a name table update. Okay, so we should just be able to compare, or no, we can, if we just want to check if bit 1 is set, then and binary like that. So, yeah. Branch not equal. So if it's set, if that bit's set, then it's an attribute table. If it's equal, that means that bit's clear, and we're doing a name table read. Our name table row right. They're both gonna be done the same way. We got the pointer set in the buffer. It's similar to before, where we're copying over and the way I did this before is use y as a counter, or x as a counter and y as a and x goes from 1 to 32. But okay, let's see. Load name table row. X is 1, y is 0. Load. $32 bytes of data into name table update 2 through 33. Is that right? Because index 0 and 1 have the address, so it's 2. And then instead of ending at 31, it's going to end at 32, 33. Yeah, so in 33 minus 2 is 31 plus 2 itself. Okay, I think that's right. So load A with the pointer. Index is 0. Increment Y. Increment X. X was 1. Now it's 2. And store name table update. Index X. Compare. If it's not done, row. Load name table row again and keep doing it. Just gonna put well, maybe we just want to update the pointer here, but we need to know if it's up or down. Because the problem is updating the pointers there, then we need to know which segment we're in once again. Okay. Now there's some other things we have to do. We have to tell tell NMI which type of update. We have to set name table update length. And we need to set it to, it should be 34. Yeah, 34 tile row, when you set it to tile row. Oh. Okay, so that'll tell NMI what we want it to do. We want it to update a row's worth of tiles. Increment pointer for next time. And actually, I think it's easiest to do it here. For scroll ups, we're gonna decrement it. In downs, we're gonna increment it. This is gonna get super messy. Trying to compress data. Right now it's all uncompressed. But anyway, I gotta get this stuff working and then worry about compression. Anyway. That is future Paul's problem. Okay. Down, we want to increment. We'll just assume down for now, because that's all we're getting working. We have the pointer. We want to increment it by 32. which happens to be the same value of x right now. But okay, so where's my is it yeah, so this is the low byte. Load nat pointer. Add. So that's gonna clear the carry, and then add 32. STA nat pointer. Then we're going to branch. I think I've got a macro for 16-bit maths. Oops. I don't know. Let's not worry about that. Okay, so branch if carry clear. Oh no, carry set. If carry set, I need to get better at this anyway. Oh, that's not right. Oh, that's a subtraction. So if the carry is clear, we're not going to perform an extra add. If the carry is set, we're going to inc nat pointer +1. Yep, okay. So increment the low byte by 32. If carry is clear, we're not going to do anything. If it's set, then we need to increment the high byte. I could create my own macro to increment a pointer, I guess, or decrement. Anyway, so that'll increment the pointer, and no, we don't want to do the attribute table. So let's, when that's done, we need to skip down here, which is going to be fill done. And so if we're doing this right, our colors will all be wrong, but every well, and we gotta go I'm relying on my name table, my NMI code to be proper that I wrote last. Stream. It's pretty simple though. It works effectively the same as all the other stuff. It's just instead of updating 56 bytes, it updates 32. Okay. Well, that didn't do a dang thing. So we load scroll Y. Load scroll count. Are we incrementing scroll count? Should be. Increment scroll count. Maybe our mask, our segment was wrong. Branch. Maybe we can set a. Just gonna make sure I'm loading the right file here. Just mess around with stuff. Open 1122. Let's see. Oh, I think I'm doing it in the wrong spot. I think I'm updating the wrong table. My code assumes that my NMI assumes that I'm updating this name table, but that's not right. Let's watch it. Yep. So it's putting the updates in the wrong spot. We gotta fix that. But my, wait. Because I just put the address. It's actually a problem in my set nat pointer. So this address is wrong. I have it set to 2BC8, which is what, here? Something. 2. Where's 2B? 6. That sounds like a, is that a attribute table address? To BC8. That looks like here. That's attribute tables. What am I doing? Oh, I'm subtracting 56. Yeah, that's why I don't want that. I want 2C100 of, because where do I really want it? I want to start updating right here, which is just 2C100. Well, it looks like it's not incrementing. It keeps updating the same row. Oh, so I increment the pointer. I also have to increment the address in the name table update. Okay. But is it doing a whole row's worth? It looks like it's doing 0 through 30. I'm missing. Anyway, the address is right. The length should be right. It's 32 plus the address, 34. Just like this was 56, but plus the address. So I think I'm not, because X, oh yeah, X increments from 1 to 33. That's why I missed a byte. Okay. Now, yeah, see, and this is why I always subtracted 56 from the address. Maybe I do like subtracting 32. Otherwise, you have to because I can't post increment it because it's gonna go get used after the fact. I'm setting it up so it's like if I have, yeah, it does actually. There was a method to my madness because every time I come in from the previous frame, I have to increment because I'm not getting the initialization called again. So we'll do it again. Although I wish I got rid of my code. All right, so 2C0 minus 32. For now this address is going to get modified for the attribute table. I guess I could store it in temporary. I might also just be able to make a new buffer, but I don't really want to do that. Anyway, let's get this working. All right, so we want to subtract 32. So what's that? 2C100. Whoops. C, no, dang, 2C100 minus 32. So 2BCE. BCE. Dang it. Okay, so that's at 2BCE. So now we have to start by increment buffer address. Let's just steal our increment code down here. So this is name table update is the first index. Just do that to denote that as it's an array. Okay. We're getting a range error. 481. Way back here. Change that to a jump not equal with our handy macros. Let's see. What happened? We had stuff working. It's updating over there again. What happened? Oh, wait. We got to jump over attribute tables. That's what we're doing. We're updating attribute tables. Right? 2C100. We subtract 32. Definitely updating attribute tables if you look at that. We're updating attribute tables for name table 0. Mess up my math somehow. So the first time we come in, we should increment to 2C100. Pull the. Oh wait, where am I setting my pointer? Oh, I set my pointer up here. Setting that pointer. Why am I back to updating attribute tables? To BCE. Decimal 32. I'm gonna pull out the debugger. But why? It's updating 32 tiles now. I don't know. I'm gonna have to pull the debugger here. Oh, that's why I subtracted hex 32, which is not decimal 32. 2C0 0 decimal minus 32 equals hex 2BE0. All right, so 2BE0 plus 32 is 2C100. Okay. I just don't think this is going to work, but it should be closer. So there's a couple tiles getting updated. A little bit more every time. It's only like updating 4 tiles or something. That's weird. Let's look at the... It's still updating attribute tables. Gosh, what the deal? E0. Is there math going on somewhere else that I don't realize? But if I said 2C100, it's right the first time. Let's just look at the debugger. All right. Okay. Stop here. We'll set. Actually, we should just be able to run. Okay. Here's our scroll count. Now we need to see the memory viewer. And our name table. Name table update. Where did I put that sucker? Oh, I think it's beginning of BSS. Yep, name table update is the beginning of BSS. Should be. I also want to see name table update length. So here I've got it visible here. Pointer. Okay. So 2BE0, there it is. All right, so let's do some stepping. So and scroll count. What's scroll count? Oh, do we have it here? Let's get that guy posted up. So scroll count's 0. So we're going to do name table update. We load it with 2B. Clear carry. We add 20, which is 32. Oh, that's the problem. My buffer's not little Indian. Sucker. My buffer is big Indian because when you write to the PPU adder, you write the most significant bit first. That Indian getting us. All right. I think I gotta toggle that breakpoint off. Scrolling forever. I think that's, yeah. All right. I still don't know if it's, oh, I think it worked. Because that way's got pine trees. Left has rocks and wells. And down has these dead trees. And the attribute tables are all wrong because we haven't done those yet. Let's watch it in action. All right. So as it scrolls, you're going to see this. So the blue is the current visible screen. The edge right in front of it is going to be updating. And behind it. So it can't do it twice. Messes it all up. But it's so fast. Let's maybe single step it with a debugger. These windows are so big and I can't make them smaller. All right. So, whoops, what happened here? Oh, the viewer doesn't like viewer doesn't like it. I have to like set the update to something else. Let's see what happens. Okay. Yep, you can see update 1 row, 2 rows, and then it's not going to do anything, not going to do anything. That's when I would have done the attribute table read and then write. And then boom, 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 boom. Yeah. Oh, it's actually in this window thing because here's the viewable. Anyway. It's doing our updates. Look at that. Done. So I guess we try to get up working. Let's see it out. See if we can knock out the ups, and then maybe call it a stream. Although we started good, 15 some minutes late. Okay. So let's start with the set nat pointer. Now here we're going to be decrementing by 32 every frame. So we actually want to set it to the room plus 888 because 888 tiles. Well, that's 808 bytes. Excuse me, which is 832 name table plus 56 attribute. So it's really, we could use the pointer for the attribute table data because that's the end, but I don't really want to have to do that. We have the beginning, we'll have the end as a function of the beginning. So we have to add 340. So play field tile count equals 832. So yeah, that's how we do it. So for up, I'm doing some subtractions, but okay, so oh, that's scrolling. Yeah. So we'll want to do room 0 for scrolling up. So I'm setting the upper byte to the name table attribute table pointer. I need to set both of them. And then I need to add oops. Then I need to add 832. Now, inc to point to the end. Can we just do that math here, though? Room 0. Well, probably not. I mean, we could. But then that's really not going to work for lookup tables. So 832 is a 16-bit number. We need to add two 16-bit numbers. which is 40, and then 3 do the carry. So I'm just going to write it in here because equals OX 340. So I guess we can should be able to do it up here, can't we? While we load the pointer. So add OX40 and carry and where's my and sign? Oh, damn it. Okay. So I want to clear the carry, add 40. Store net pointer. Now the carry is set if we need it to be. Load room high byte, store in the high pointer, and then so if the carry's set, we want to increment. Branch of carry clear. Inc net pointer. If carry set, need to inc. Oh, but we also need to add 3. Okay. So let's not store it yet. I didn't need to store it here either. Load room 0, add 40, store. Load the high byte, increment. I don't want to clear the carry. I just want to add with carry 1. Not certain about my math here. Part of me says I should do the high byte first. If I do the high byte first and just add 3, then do the low byte, and if the low byte had a carry, then just increment the high byte. Instead of try to maintain that carry bit. don't care about the carry. Add a carry. 03. And then I might want to even increment an extra 32 because every time I come in, I'm going to subtract. No, not. Maybe. We'll see. Okay. So we store in the high byte. We load room 0. We add. We want to maintain the carry. Add. For 0 to the low byte. Store in pointer. Now branch if carry is clear. Inc nat pointer +1. Oh. So the pointer is looking at the first byte that's past the end. But what I am gonna do every time is decrement the pointer by 32. Because it's at the end. I'm going to decrement it by 32, which basically to go up a row and then fill. And actually, I'm going to decrement it by 64 because as I fill, I'm gonna increment by 32. I have to subtract by 64 every time because my filling is adding. So I actually need to add 340 plus 32, which is decimal 20, plus our auto inc 64, which equals 0x20. And I think I can just go maybe plus 20 or even plus 64. Come on, CC65, can you handle that? Plus 64. Okay, so initial starting address is going to be, it's going to be here. Because as we're scrolling up, this is the first update we're going to do, but it's always going to add 60. Well, we'll worry about that. going to be there, which is 2460. And then it's going to fill. And when we come to it the next time, we're going to subtract 64. So we'll do 2460 minus 64. Two 460 minus 64. So hex 2460 minus decimal 64 equals 2420. And the address does start at the bottom now. 420. Okay. All right. So this is different because if it's vertical, I'm sorry, if it's down, we increment by 32. If it's up, we increment, we decrement by 64. So that's a difference. Down, inc by 32. Up, dec 64. Tile row stays the same. Loading is going to stay the same. Up, we're going to dec by 64. So we have two different code chunks happening based on inc dec, which is the scroll dir. This is where I feel like we have lots of code happening. I don't know. Put this, my note says put this in a subroutine, and here I am. Or we're going to have two different chunks of code based on which one we're doing. The loading function is the same every time. This could be in a subroutine. Instead of having these branches. Or not. So I think I'm just going to do two different chunks if we're up or down. So LDA scroll dir and it's like up. Where do I have that thing at the top of main? Yeah, UL bit, up left bit. So we AND with the UL bit branch. Equal. Up scroll. Or not equal. Yeah. If it's not equal, that means the up left bit is set. Gosh, this massive code. Anyway. So this is an up. Decrement by 64. And if it's set, then we did a borrow. Think it works. Where's your money? Mine's on no. But maybe it does. Oh, wait a second. Let's say it doesn't work. Why doesn't it work? Am I jumping over attribute tables like I'm supposed to? I don't think so. Because let's just reset this. I won't execute it though. We're going to start updating right here. Right? This row. Boom, boom, boom. After 1, 2, 3, 4 rows, we run into the attribute tables. And then we're updating attribute tables as if they're name tables. So on scroll count, whatever that is, we have to update the address to skip over the attribute tables. Let's just prove I'm right and see if we have any other bugs. It's going to kind of work. I guess that's kind of working. I didn't update these tiles at all though, like I wanted it to. Let's do it slowly. Up, frame 1. Oh, see it like, what happened? It's updating here. Doesn't show up here though. It made an update right here. What's going on? Oh, it's acting like I'm scrolling. Oh no, that's... It's put them in the wrong spot. Or is it adding 3064 or something? All right, running. So I do 1 frame worth. We'll hit up. We'll execute a frame. We'll turn the up button off. So it started scrolling, but for whatever reason, it put what looks like this row of data, it put here. So it looks like my data is wrong, as is my pointer, my location. Well, I subtracted 64 and then I subtracted 64 again. That's not... Oh, do we need to always add 60? No. Hold on a second. So the pointer to the file doesn't change. Well, it does, but it doesn't. So the pointer to the file is only going to change by 32. We're always going to subtract 32, not 64. Yeah. I'm thinking about these things as if they're changing, but they're not. I think you know what I mean. They only change by 32. Okay. Let's so going back to this. All right, so the pointer is set to point to this tile. If we subtract 32, it goes there. Okay. So maybe my pointer's right. I'm subtracting 32. Let's see here. Scroll up. Oh, see 64. So I'm adding 64. Each time I'm going to subtract 32 though. So we point to the end of the name table data, then we add an extra 32 because as we go up, we're going to keep subtracting 32. Okay, so that should fix the pointer. Now, oops. Oh, looks like Koitsu's hosting me. Thanks, Koitsu. All right. So I'm decrementing by 64, but that's not actually right. So the update buffer. Oh, and did I even set that right? Let's go down here. Yeah, so 2460, which is, we want to start updating here, which is 2460. But we want to do minus, not 64, minus 32. As the index increments by 32, the pointers don't increment by 32. Those stay where they were. That's what I was doing wrong. So I think this is going to be 2430. What is it? 2460 minus a decimal 32, which is 2420, 2440. Yeah, I was wrong. That's why I use a calculator. 2440. No. Plus, right? Because I'm always gonna subtract. So that should be 2480. 2460 plus decimal 32. Yeah. Getting all kinds of math wrong. Okay. So when we're initializing, we're adding an extra 32. And when we're running, we're subtracting so that we move up a line, up a row each time. Now we're still not skipping over attribute tables like we should. What did I do? Load name table rows already defined. Well, yeah, it is. How come I didn't catch that? It didn't catch that last time. Load. And then we got a range error in main. How come that code didn't happen before? This errors didn't happen. All right, so 526. And I'm gonna get these range errors if I was putting things in subroutines like I should be. Okay. All right. Did you go? Or is this a breakpoint? Oh, it's running. Down works. Control T. Up. Okay. Okay. I think. Let's see. Let's do it one frame at a time. Up. Frame. Okay, what's the first? What's happened? The first one here. That looks right. Not 100% sure if it's the right data. I forget what that screen looks like. Oh, that's probably maybe right. Let's just open up tiled and look at that room. Just tiled. And I think this is supposed to be room 0. Yeah, up was supposed to be first choice. So file. Room 0 is like the fixed version. It should be loading a bunch of bricks. It looks like it's loading this or something. No, it's loading waterfall. That's not room 0. What room is that? I remember drawing a room like that. It looks like this one. No. Open. Room 0. Open. Room 1. Open. Room 2. That was right. File open. Room 3. So it's got like waterfalls, which looks like this room. Yeah, a few tiles, half a screen. It's putting them in the right spot, but my pointer to the file is wrong. It looks most like this file, which is room 1. And we're supposed to be room 0. So somehow it's pointing at, and I think I'm arranged 0, 1, 2. So I must have incremented too far. That's probably what's going on, my pointer. It looks not too shabby though. Let's see. So now it's updating. Yeah, so it looks like it's my pointer is pointing somewhere in room 1 instead of room 0 like it's supposed to be. But let's just keep going. There, it scrolled into it. Maybe it's already doing that and I wasn't watching. So now it's going to start updating attribute tables when it shouldn't be. It's going to do that for a few frames. And then, oh, you know what? It's updating. Oh, you're probably right. But look what else is happening. It incremented from 2,4,000 what's to 2,3,000, which is the previous name table. But that's going to be handled in my, when you skip over the attribute table, jump to the bottom of the current name table. So whenever we get to that point, make sure to do it. Let's find our pointer problem here. Okay, so high byte. Yeah. We're going to start with high byte. Room 0. So I'm adding 340. But let's double check that. So 340 is 832. 832 plus 56 is 88. 888. Yeah, that's right, because there's 32 per row times 26. Yeah, 832 is the right number. 832 in hex is 340. So I have the high byte I load it. I add with carry. Oh, wait, but okay. We'll go ahead. So we add with carry 3 in hex, which is right. We store in the high byte. Okay. We load room 0 low byte. We add 40. Oh, you know what? I bet it's very possible that CA65 isn't taking this. This is a decimal number and this is a hex and this is a decimal. It might be saying hex 40 plus 32. Let's just not leave that up to interpretation. So do it ourselves. So 340 plus a decimal 32 is 360. Yeah. Because that would have, yeah, that sounds about right. Because if I did hex 340 plus a hex 32, that would have been a 372, which anyway, I'm not sure if that would have got me past attribute tables. I think it would have put me in the attribute tables. 382 or 882 is in the attribute tables. The buffer is right. Let's go ahead and check the pointer for up. So this is the, oh, wait a second. So I'm decrementing the, okay. I want the pointer to be accurate when it starts. The address is offset because we always want, but the pointer we modify afterwards. So really I want to be, I'm adding 32, but I want to subtract it because I want the pointer to be pointing at this tile in the data. Sakanakatao, I can never pronounce your name. What? I'm just gonna call you Sakan. Oh. And that's probably related to what's causing me problems here. Oh, no, I think it's, okay, so you're asking about this, what is PF tiles plus auto ink 64? And really this should be 32. So because we're doing upward scroll, my data is arranged vertically, basically. So the play field is 888 bytes, but it's 832. Yeah, it should, and I corrected the code, but didn't correct the comment. Anytime I have a 64 in the comments, really, I mean 32. Whoops, not there though. Attribute table, that's right. Okay. But now I gotta. So the data we want to increment to the end, but not really to the end. It's the end minus 32. So really, it's hex 340 minus 32. So really, it's 320 for the data pointer. So it should be minus a row of 32 equals 320. Yeah. So the pointer on entry, the pointer is correct, and then we post decrement. On entry, the buffer is wrong because we just performed the last update, so we need to pre-decrement. I feel like I still have something wrong, but maybe not. Yeah, it's still in the waterfall. This should look not like this. It's drawing this line right here. So what? It's off by like 7 rows or something. Let's think about this again. Okay, so I have 26 rows, right? Because there's 30 in the whole screen minus my heads-up display. 26 rows in my playfield. The pointer points to the very first row. Really, we just want to increment it by 25 so that the pointer is pointing at the last row. So 25 times 32. Yeah, 320. So am I doing my math wrong? I want to increment the pointer by 320. Maybe my carry is not getting set right or something, but it's going too far. Okay, so pointer plus hex 320. Room 0, high byte. Because right here, room 0, I got name table and attribute table. I'm trying to increment. Am I not incrementing? Because my pointer's at the beginning of the file. And I want to increment to the last row of tile data. Because that's going to be the first one as we supposed to wrap at 26. Well, when I'm scrolling, yes, but right now I'm having a problem with the source tile data, not the scrolling. So I have a pointer to the beginning of the name table data, beginning of the tiles, and I want to have it point to the last row, and then I'm going to keep decrementing because I'm scrolling up the pointer, that is. So I load the high byte. I add 3 to it, and I store it in the high byte. I load the low byte. Well, yes. So here's my method. I because I know my data is always going to be within. Yeah. Here, well, let me explain it, and maybe I initially did in opposite order, but I wasn't trusting what I was doing. Here's the thing. So if there's a carry in the high byte, then that meant that my data was past addressable CPU range. So I'm not going to have a carry there. So the high byte is always going to have, I'm always going to add hex 03, store it in the high byte. Now the low byte could cause a carry into the high byte. So when I load the low byte, I'm never going to have a carry here. I shouldn't. I load the low byte, I add 20, and I store it. If there's a carry from the low byte addition, then I increment the high byte. So I know you normally do them in the other order, but because I know there's no carry from the high, yeah, and here's my increment for the high byte if it occurred. It was just easier that way instead of trying to maintain the carry through the load of the high byte. I just need to look at the I just need do a look at the debugger and why my pointer isn't what I think it is. Oh wait, does it? So here, no, because I want to clear the carry. Because this add macro is clear carry, then add with carry. So I know it's clear coming in, and then if there was a carry in this low add, then I increment branch of carry clear. So if the carry is set, then I increment the high byte. I don't care about clearing the carry before this because I don't care about it. Does it oh, it always includes the carry. That's right. I'm just thinking that I had forgot that it includes. So when you add, yeah, add with carry, the carry will get set, but it's also included. So if you want to add, yeah, that's where I'm being dumb. That's probably it. Okay, that looks right. We just have to skip the name tables. Although, is it? This one should be... Oh, let's look at our source data. Nope, I started drawing things there. No, room 0. Room 0. Yep, that's right. Okay. Okay. Thanks for that. Yeah. Well, I knew that too. It's just like... It's the carrier is associated twice, and so I was fixating on the one and forgetting. And I don't think I've done any math that included the carry yet, so yeah. Still some cobwebs in there. All right. Let's quit that. So we need to skip over the attribute tables. And that will happen. So scroll count. Which scroll count is that happening on? So we do 4 pixels per frame. The heads up, we're gonna do 4 rows. So yeah, now I can swap the 2 cases and lose the... Yeah. Yeah, we could do that. All right. Yeah, and that's why I needed to get that knowledge hole filled. Okay. So we'll load room 0 low byte, add, which clears, and start in the low byte. Load the high byte, and load doesn't affect the carry, right? No. Just the 0 or whatever. Okay, so load the high byte and add with carry, and then we don't need this other junk. Yeah, see? Oh, because I'm clearing. Gosh, maybe I shouldn't use these damn macros. Yeah. I think I'm confusing myself. I get in the habit of, oh yes, just use the macro. We load it, we clear carry, we add with carry, which is already clear, but now the carry will be set if there was a carry. We store it, we load the high, we add with carry, which would have been set previously, and store it. Okay. Okay. So down still works. Left still works. Yep. All right. Now let's skip. So the pointer doesn't have to skip over anything. It's just the address. Yeah. Okay. So skip over so we should be able to use our scroll counter that increments every frame. So it starts at 0. Let's see. So we have 4 rows, which should take 16 frames. It was 32 pixels. 4 pixels per frame. 8. Probably. I've been doing it all the time. Yeah. See, that's how I do it. It's all over the place. I'm just going to leave it from now. See, we fixed a bigger problem. Because yeah. Okay. So 8. Yeah, it's 8 frames because we do 1 frame, 2 frames, 3, 4 for attribute tables, 5, 6, 7, 8. So it's 0 through 7 are correct, but if it equals 8, then that means this frame just jumped into the name tables. When scroll count equals 8. Yeah. That was my whole problem, is I wasn't thinking about how to carry. I wasn't realizing I was using carry as a flag only and not as part of the math. So compare with 8. So the attribute tables are 64 bytes in total, so but we want to stay, we can just set it to what we want. Which is what I think I'm going to do. Instead of trying to math it, because we always know what it should be. So we know that we're in the attribute tables, and what the next byte that we want to update is going to be 27A0. The first row at the bottom of the attribute table. So we store that in the high byte of name table update. AO plus 1. And we should only have to do that once. Oh. Yeah. All right. We did it. Attribute tables still haven't been updated, but this looks like this. Sweet. So 1 o'clock here. That was a pretty successful stream. I'm going to call that good. We'll do our recap here. My Nintendo CRT camera's all messed up right now, so I'm not gonna do that today. That, and I gave my cartridge to some dude at Midwest. But anyway, all right. Let's restart this guy. All right, so this is a recap of stream 15. Last time we had automatic updates and scrolling working for left and right, and we started figuring out our game plan for scrolling vertically. We wrote some new NMI routines last time, and today we started using them. So the first thing we did is we started our scrolling. So the code, anytime we hit up or down, it automatically scrolled as we wanted. And we ignored any of the updates. But then we started working on down updates. So we have those working. This is the starting mode. And it's going to start updating the buffers here. So those 4 sprites, where are those from? Oh, you recognize these. You know what these are. This whole project started from your example, your CA65 example. They just happen to still be there. I haven't gotten rid of them. So to scroll down, it's going to start filling in these attribute these tiles, and we're not working on attribute tables yet, just getting the tiles right. Yeah, still those. So let's look at the code here. So when we're updating, scrolling vertically, we have a 4-frame segment. The first 2 frames write a row of tile data, and then the second 2 frames read and write, but we haven't gotten to that point yet. So we can show slow-mo. So we'll start with the frame scrolling down. Whoops. Or just go forever. Okay. I think I can. Well, I don't want to 2x it because then you won't be able to see anything else on the screen. So here, nothing's updated. We update 1 row, update another row. This frame would be where we would read the attribute table row. And then this frame would be where we'd write a nibble's worth. And then we update again. And so we keep doing those updates right here. And if you look at the screen, it's going to be updating while we scroll. You won't see any glitches. You won't see any tile glitches. You'll see attribute tables are wrong because we haven't done that step yet. But we're scrolling into the next room 4 pixels at a time. And when we get to the end, it'll stop. So this room, if you just look at the tiles, we scroll down, so that's supposed to be room 2. Has the same tile makeup as this one. Next time we'll work on attribute tables, but the tiles are all correct. So then we also got up scrolling, which is basically the same, except all the data is mostly arranged conveniently for scrolling down because the file pointer is at the top of the data. So to scroll up, we had to take the file pointer and increment it to the end. And I had some kind point outs that I was doing all of my math wrong. My add with carries, I was only treating the carry flag, the carry bit, like a flag. I was neglecting the fact that add with carry is add, and if the carry bit's set, then that's an extra bit to add. So I appreciate that. And now I can show you the upward scrolling. The other thing that we had to do is there's only 4 rows, and the next address above that is actually attribute tables. So we have somewhere. Here it is. So on scroll count 8, that's when we jumped in. The address decrement would have went into the attribute tables. So then we reset the address to the bottom of that name table. So we'll do that. Quick. Hit up, frame. And so now you'll start to see these tiles update as we scroll up, and we should have clean scrolling here. So there's 1 table, 1 row, 2 rows, and it's starting to appear here. Although, am I skipping? Looks like every frame I'm scrolling by, that's right, okay. Every frame I am scrolling by 4, but the tiles only update every 2, then not for 2. So update, attribute table, attribute table, update, attribute table, attribute table. We get to the end and it stops. And so this room should be up is room 0. So if you just look at the tiles, the clouds, blocks, vines, ladder, this is all correct. So we have pretty good progress there, and next time we will be doing our nibble writes to the attribute tables to keep those updates in that 4-row buffer. So everybody have a good rest of your week. And got one last comment here. The sub, low byte, branch, carry, deck, high byte, where you put the do. Yeah, so it's appropriate for an 8-bit minuted from a 16-bit subtrahend, which makes in the case that you don't need to fix it. Yeah. Anyway, so that one might be okay, but I still, yeah, because here, but I need to go back and look through some of the stuff and make sure I'm not being dumb all the time, just to have a better understanding of that, so I don't revert to my old ways. But we'll see you guys next week, and I will. We will get the attribute tables done. I'm probably gonna have to make an extra pointer for the attribute tables instead of using the same name table. Some other temporary storage, but anyway, we'll get there next week. You guys take it easy.